Good day everyone, we are Group 3. We are here to present a video about Module 5, which is Understanding Z-Score, Probability, and Percentiles. After going through this video presentation, you are expected to convert a normal random variable to a standard normal variable and vice versa. Compute probabilities and percentiles using the standard normal table. The standard normal distribution has the special case where the mean is equal to 0 and the standard deviation is equal to 1. The normally distributed random variable under the standard normal distribution is known as standard normal variable, and it's always denoted by letter Z. We use the standard score, also known as Z-scores or Z-value, to represent raw scores may be composed of large values that cannot be accommodated at the baseline of the normal curve. Thus, conversion from normal random variable x to standard normal variable z is highly encouraged. In addition, if someone wants to determine the exact of or raw scores in the standard normal distribution, conversion from standard normal variable to normal random variable will be done. Below are the formula to be used in converting normal random variable x to standard normal variable z, also known as the z-score. So, z-score for population. Z is equal to x minus mean divided by deviation, where the z is equal to z-score or z-value. X is equal to raw score or the given measurement. Mean is population mean, and deviation for population standard deviation. And z, for example, z is equal to x minus sample mean divided by s, where z is equal to z-score or z-value, x is equal to raw score or the given measurement, x sample mean, s is to sample standard deviation. On the other hand, the formula to be used in converting standard normal variable z to normal random variable x is x is equal to mean plus deviation of z, where x is equal to raw score, z is equal to z-score, z-value, population mean, standard deviation. Example number 1. Given the mean 50 and the standard deviation 5 of a population of statistics and probability scores, find the z-value that corresponds to a score x is equal to 65. So firstly, we draw the bell curve and put the mean 50 in the middle. So since the deviation is 5, we simply add 5 to the 50. So 50 plus 5 is equal to 55. In the second row is 60, in the third 65. In the left side, we simply subtract the 5 into 50. So 50 minus 5 is equal to 45, then 40, then 35. Second, we simply subtract the 65 to 50. So 65 minus 50 is equal to 15. Then we bring down the 5 over here. We bring down the 5 over here. So we have now the 15 divided by 5. So 15 divided by 5 is equal to 3. Therefore, the z-value that corresponds to a score x 65 is 3 in a population distribution. Example number 2. The mean is equal to 20 and the standard deviation is equal to 10 of a set of summative scores of a grade 11 class. Find the z-value that corresponds to a score x is equal to 32. So first, we illustrate the bell curve and we write the mean in the middle of bell curve. Since the deviation is 10, we simply add 10 plus 20 to the first populations. So the first population is 30, the second population is 40, the third population is 50. As we can see, the 32 is located in 1.2 population. Therefore, the z-value that corresponds to a score x is equal to 32 is 1.2 in a population distribution. Here's another topic: computing the probabilities using the standard normal table. The Z values are matched with specific areas under the normal curve using the standard normal table. The area under the curve is the probability. This probability gives the desired percentage for x. The following notations for a random variable are used in various solutions concerning the normal curve. Z is greater than A but less than B denotes the probability that the Z score is between A and B. Z is greater than A denotes the probability that the Z score is greater than A. And A is less than Z denotes the probability that the Z score is less than A. Here's the example. Find the proportion of the area above -2. Step 1. Draw the normal curve and shade the required region. Note, to shade the required region, start from -2 Z value going to the right of the normal curve. Step 2. Find the area that corresponds to the Z value. Note, in the standard normal table in this module, the area that corresponds to Z is equal to 2 is the same as the area that corresponds to Z is equal to -2. Step 3. Examine the graph and use probability notations to form the equation. Note, add 0.5 to 0.4772 since half of the normal curve is shaded. 0.4772 plus 0.5 is equal to 0.9772. Therefore, the proportion of the area above Z is equal to -1 is 0.9772. Here's another topic. Computing percentile using the standard normal table. A percentile is a measure of relative standing. It is descriptive measure of the relationship of a measurement to the rest of the data. For example, you got 78 in a test in statistics and probability, and you want to know how's your standing in comparison with your classmates. If your teacher tells you that you scored at the 89th percentile, then it means that 89% of the grades were lower than yours and 11% lies above or higher. Four important things to remember. Number 1, a probability value corresponds to an area under the normal curve. Number 2, the numbers in the body of the table of areas under the normal curve or Z table, also known as the standard normal table, are areas of or probability. Number 3, Z scores to the left of the mean are negative values. Number 4, in locating area at the body of the table, if the exact area is not available, we take the nearest area. Example number 1. Find the 95th percentile of a normal curve. Step 1. Express 95% as probability. So, 95% is 0.9500. Step 2. Split 0.95 into 0.5000 and 0.4500. Step 3. Locate 0.4500 in Z table. Note, since 0.4500 is not found in the table, we take the nearest area, which is 0.4495 and 0.4505. Step 4. Find the average of the two values. 1.65 plus 1.64 divided by 2 is equal to 1.645. Therefore, the 95th percentile is Z is equal to 1.645. Here's another topic. Finding Z-score for a percentile. The distribution of resting pulse rates of all students at Santa Maria High School was approximately normal with mean 80 beats per minute and standard deviation 9 beats per minute. The school nurse plans to provide additional screening to students whose resting pulse rate are in the top 30% of the students who were tested. Now, what is the minimum resting pulse rate at the school for students who will receive additional screening? Round to the nearest whole number. So, since we're looking for 30%, we assume that the shaded area is 30% or 0.3. This area is 30% or 0.3. So what we can do, we can use a z-table to say for what z-score is 70% of the distribution less than that. And then we can take that z-score and use the mean and the standard deviation to come up with an actual value. So here in the z-table, we're going to find the 70%. So as you can see, the nearest 70% is here, 0.719, 0.7019. It is located in 0.53, 0.53. So 0.53, and we just now have to figure out what value gives us a z-score of 0.53. Well, this just means 0.53 standard deviations above the mean. So to get the value, we will take our mean and we will add 0.53 standard deviation. So 0.53 times 9, and this will get us 4.77. 4.77 plus 80, since the mean is 80. So 4.77 plus 80 is equal to 84.77. Here, 84.77. And they want us to round to the nearest whole number. So they want us to round to the nearest whole number. So we will just round to 85 bits per minute. So the answer is 85 bits per minute.